I spent 11 years signing off on service recommendations at one of the largest Mazda dealer groups in the country. And for most of that time, I watched techs pour the same oil into Skyactiv engines at 100,000 miles that they put in at 10,000 miles. Nobody questioned it. The factory spec said 0W20. The spec sheet matched, the box matched. Done. It wasn't until we started pulling Skyactiv G engines for teardowns after high mileage trade-ins that I realized what was quietly happening inside those combustion chambers. And once you see it, you can't unsee it. This is what I wasn't allowed to say loudly back then. Here's the thing. Mazda's Skyactiv technology is genuinely impressive engineering. The 14:1 compression ratio in the naturally aspirated Skyactiv G was groundbreaking when it launched. Higher compression means more thermal efficiency, which is why these engines deliver better fuel economy than their displacement suggests. Mazda built the entire Skyactiv platform around efficiency, and the 0W20 oil specification was a calculated part of that design. Thinner oil creates less internal friction. Less friction means better fuel economy numbers, and better fuel economy numbers matter to regulators, to consumers, and to Mazda's fleet average emissions ratings. That reasoning is not wrong. At the time of manufacture, with fresh seals, new rings, tight tolerances, and a short break-in period, 0W20 does exactly what Mazda intended. The logic holds. The engineering is sound, but here is where the story gets complicated. Engines age. That's not a scandal, it's physics. And the way a Skyactiv engine ages over 80,000 miles creates a set of conditions that Mazda's original spec sheet never had to account for, because spec sheets describe new engines in ideal states. What actually matters is what your engine looks like. Right now, today, with the miles it has on it. Let me explain what happens to an engine's internal tolerances over time. Piston rings are designed to maintain a specific gap against the cylinder wall, tight enough to seal combustion gases, loose enough to move without seizing. Think of it like a rubber gasket pressed against a glass surface. When that gasket is new, the seal is nearly perfect. As the gasket wears over years of heat cycling and pressure, microscopic gaps develop. The seal still works, but it's no longer the same seal it was when it left the factory. Now apply that same concept to your piston rings and cylinder walls. As tolerances open slightly with wear, combustion gases can migrate past the rings in small amounts, a phenomenon called blow-by. This pushes oil contamination, moisture, and combustion byproducts into the crankcase. It also means the oil film between moving metal surfaces needs to work harder to maintain separation. And if that oil film is already very thin, as 0W20 is designed to be, there's less cushion when things get tight. Pay attention to this number. Blackstone Laboratories, which analyzes used engine oil from tens of thousands of consumer vehicles every year, has documented that high mileage engines with blow-by show measurably higher wear metal content in their used oil reports compared to newer engines running the same specification. Iron, aluminum, chromium, the metals that come from cylinder walls, pistons, and bearing surfaces, all climb. It doesn't happen overnight. But the trend across high mileage Skyactiv samples is consistent enough that experienced analysts take note. And that's not even the most important part. Mazda's Skyactiv G engine uses a high-pressure fuel injection system that, like many modern direct injection setups, introduces the possibility of fuel dilution in the oil. Fuel that doesn't fully combust during cold starts and short trips can wash past the rings and mix with the engine oil. This is not unique to Mazda. It's a known characteristic of direct injection engines generally, but fuel dilution thins oil. It reduces viscosity. An oil that started as a 0W20 can behave closer to a 0W16 after fuel dilution from regular short trip driving. For a new engine with tight tolerances, that margin is manageable. For a high mileage engine with slightly looser tolerances, that same margin may be less forgiving. Now here's where it gets genuinely interesting, because Mazda has actually shifted its own position on this. In several international markets, Mazda began listing viscosity W30 as an acceptable alternative for Skyactiv G engines in vehicles used in severe duty conditions, stop-and-go traffic, towing, extreme heat, or high-mileage applications. The North American Owner's Manual for many Skyactiv models still lists OW20 as the primary specification, but it's worth knowing that the same engineering team that designed these engines has, in other contexts, acknowledged that operating conditions matter when it comes to viscosity selection. This is not Mazda hiding something or deceiving owners. The 0W20 specification is legitimate and appropriate for many drivers in many conditions, but the full picture of Mazda's own engineering guidance is broader than what most North American owners ever see, because manuals are often market-specific and don't carry the full range of conditional recommendations. Wait until you hear what the teardown technician told me when we pulled the first high-mileage Skyactiv at around 95,000 miles. He described the soot varnish coating on the underside of the valve cover as looking like the inside of a well-used cast iron pan. dark, with a sticky residue that's smeared slightly under a gloved finger. That's oil oxidation. That's what happens when oil is thermally stressed over many heat cycles, when it absorbs combustion byproducts over time, when it's asked to do the same job with a progressively more contaminated crankcase environment. The varnish itself isn't always catastrophic. Some deposit formation is normal in any engine. But heavy deposits can restrict oil flow through narrow passages, clog the tiny channels in variable valve timing, actuators, and reduce the overall efficiency of the oiling system. And a less efficient oiling system compounds the wear problem rather than solving it. The variable valve timing system is particularly sensitive here. Mazda's Skyactiv G uses a hydraulically actuated valve timing mechanism that relies on oil pressure and oil cleanliness to function correctly. The actuator passages are small. We're talking about clearances that can be measured in hundredths of a millimeter. If oil, sludge, or varnish begins to restrict those passages, the timing system responds sluggishly. That sluggish response translates into slightly off-time combustion events. Off-time combustion adds heat and pressure stress to the very rings and walls that are already managing wear-related tolerance changes. You can see how these issues build on each other. Now, this is the point where I need to be direct about what the evidence does and does not say. None of this means that every Skyactiv engine running DOW20 past 80,000 miles is heading toward failure. Many of them run cleanly and reliably, well past 150,000 miles on the factory specification. The evidence suggests that for most drivers in moderate climates, doing a healthy mix of city and highway driving with regular oil changes, the factory spec continues to perform as intended. The engineering is solid. Mazda built these engines to last. What the evidence does suggest is that certain combinations of conditions may create a situation where the calculus shifts, and you are the one best positioned to assess those conditions for your own vehicle. This next part is going to make you think about your own service schedule this week. If you are driving a Skyactiv-equipped Mazda past the 80,000 mile mark, and you are running 0W20 with oil change intervals stretched to the factory maximum, in many cases listed at 7,500 or even 10,000 miles under normal conditions, consider what that interval looks like against the reality of how you actually drive. Short trips in cold weather, stop-and-go commuting, and infrequent warm-up cycles all count as severe duty by most engineering standards, even if your dash doesn't tell you that. Severe duty typically means having the oil change interval, regardless of what oil you're running. If you have over 80,000 miles on a Skyactiv engine, pull your dipstick this week. Look at the color and consistency of the oil on the stick. Fresh DOW20 is nearly clear amber. Oil that has absorbed significant combustion byproducts turns darker, tan, then brown, then black. Rub a small amount between your thumb and forefinger. Clean oil feels smooth and slightly slippery. Degraded oil feels gritty or leaves a dirty residue that smudges. That single check, done before your next oil change is due, gives you real information about how your oil is actually holding up in your specific driving conditions. If you live in a hot climate, sustained summer temperatures above 95 degrees Fahrenheit, or if you do a significant amount of low-speed urban driving in that heat, the case for discussing a viscosity adjustment with your mechanic becomes somewhat stronger. Heat accelerates oil oxidation. Heat thins oil. In a hot operating environment, a fluid that starts as 0W20 under already marginal thermal stress may not maintain the film thickness it needs to protect metal surfaces at the micro level. Here's the conditional picture clearly. If your Skyactiv engine has under 80,000 miles, you're doing mostly highway driving in a moderate climate, and you change your oil on schedule, the evidence suggests staying with Mazda's 0W20 recommendation is entirely reasonable and well supported by the engineering. If you're past 80,000 miles and you're predominantly doing short trip city driving, or you live somewhere that sees extreme summer heat, or you've noticed any ticking or slightly louder mechanical noise at cold start that disappears after a minute of warm-up, that faint tin can rattle that fades as oil pressure builds, those are indicators worth discussing with an independent mechanic who can assess your specific engine condition. Some technicians working with high-mileage direct injection engines have found that a carefully selected 5W30 full synthetic within the API SP or ILSAC GF6 specification can provide improved film thickness without creating excessive friction losses in a well-functioning high-mileage Skyactiv engine. If your engine has documented oil consumption, meaning you're adding oil between changes rather than arriving at your change interval with the same level you started with, that's a different conversation that goes beyond viscosity choice alone. Oil consumption in these engines can involve piston ring wear, valve seal degradation, or other mechanical factors that no oil grade adjustment will solve on its own. That conversation needs a compression test, a leak down test, and an honest assessment from a qualified technician before you spend money on solutions that don't address the actual source. Let that sink in for a second. The oil in your crankcase is not just a lubricant, it's a diagnostic tool. It tells you what's happening inside an engine you can't see without pulling it apart. The color, the consistency, the smell. Burnt oil has a sharper, more acrid smell than fresh oil. And if you've ever caught a faint whiff of something burning through the cabin vents after a long highway run, that's worth paying attention to. These are signals, real ones. Not sensor codes, not dashboard lights, just chemistry and physics doing what they always do. Mazda engineered the Skyactiv platform to be a genuinely long-lived engine. The evidence on that point is solid. These engines, when maintained well, can cover significant miles. But maintaining them well past 80,000 miles may mean engaging more actively with the specifics of your driving conditions, rather than defaulting to the same routine that worked when the odometer showed 15,000. Check the oil. Know your driving pattern. Have an honest conversation with someone who can look at your engine, not just look up a spec sheet. And if you're approaching an oil change on a high-mileage Skyactiv, this is a reasonable time to ask whether your current routine is optimized for the engine you have today, not the engine that left the factory years ago. If this gave you something concrete to think about, share it with another Skyactiv owner who might be running on autopilot with their service schedule. Drop a comment below with your mileage and what your used oil looks like at change time. I'm genuinely curious what owners are seeing in the real world across different climates. And subscribe if you want the follow-up, because we're going to go deeper on what the Skyactiv D diesel owners in other markets are dealing with on the lubrication side, and that story is even more nuanced than this one.